Hey guys, what is up? This is Mike Rosada, and this is a two-part video series on three of the most amazing array methods that we have available in the JavaScript language. And these three methods are actually also three of the functions that make functional programming such a powerful paradigm. So if you want to get on board with functional programming, this is definitely something you want to learn. And if you haven't looked into that and you just want to learn about these array methods and how you can make your JavaScript code that much better, then you're in the right place. We're going to write some code. We're going to learn a lot of stuff. It's going to be fun. I hope you stay on board for both episodes. Let's get started. I even took the time to draw you this beautiful picture. And what's going on here is this is just kind of an illustration of what these three methods do. All right. So this first one is map. And map transforms items of an array, and it transforms each item. Each item goes through a function, or in the case of this illustration, it's a magical portal, and it goes through and it gets transformed into whatever you want. But that term transform, I don't want you to think that this A is like mutating into this B. That's not the case. It kind of is, but in the end, it's almost like parallel dimensions. This array is still alive and well. Nobody's hurt. No one was injured in the making of this array over here. And that's a map. So an important thing to remember with map is that if you put in 5 items, you get out 5 items. All right? So they're A's, and they get transformed to B's. And then we have filter. Very similar concept. We're putting in items of an array. They run against the function or through this dimensional portal, and they come out the other side. Again, they're not mutated. We don't lose this side of the array. We gain a new array, but it's a subset. And what that means is it could be the same length as the original array, but it can't be bigger, and most times if it did its job, it's going to be smaller. It's going to be a subset. And any items that come out on this side, if it's a filter, they have to have been items in here, because it is a filter. It's like we're flipping through a deck of cards and we're saying keep that, throw that away, keep, toss. All right, it's either keep it, get rid of it, let's move on. Reduce is the most complex of the three, and that's why it's going to get its own video. But as a little spoiler, what happens is the items go through the dimensional portal, and instead of coming out one at a time, like these two methods, they come out and they're one item. It's reduced down to one item, and we'll dig deeper on how that happens. But just for an overview, you should know that when we map, we get back an array of the same length with each item having run through a function and being transformed. When we filter, each item runs through our function and we decide if we want to keep it or get rid of it. And with reduce, each item likewise goes through our function and we turn it into a reduction, just a single item. Doesn't matter if we had 1,000 elements in this array, it comes out of a reduce as one item. All right, and so that sounds pretty easy. They might not sound that powerful, but they really are very powerful. And one of the benefits of these is that we can actually stop writing traditional loops. Like, that's pretty cool. The control flow that we're used to writing with loops, we can just throw out the window and we can start using these beautiful short array methods. I want to point something out to you here. I use chai in my videos to be able to prove to you that I'm not talking nonsense. And if you've never used chai, don't get scared. Don't even worry. It reads like English. So this is a demonstration. We're expecting 50 plus 50 to equal 100. And we know that's true. And I have this little console log. If this runs, that means the test passed. So we run it, success, you win. But you might not believe me, so I'm going to show you what happens if we expect it to equal something that's not true, and we get an assertion error over here in the debugger. It expected 100 to equal 101. So it's pretty easy to understand. I'm going to keep that success message there. And before we dive into this big piece of data, let's just do a quick mapping to see what we're dealing with using these numbers. All right, so let's make a new array, and we'll call this array actual nums. Because if you notice, the numbers in this are strings, and we want actual nums. So we can use the map method, and the map method is going to take a function, and the arguments of that function is going to go through each item of the array one at a time. And the first argument to each call to the function, because the function is going to get called, what are they, 4 items, so it'll get called 4 times. So the first item will be 10, will be 20, and then 10, then 50, then 20. The second argument is the index. So the first time this is called, it'll be 0, then 1, then 2, then 3. The first time it's 0 because we know arrays are 0 indexed, meaning they start on the 0th index. So if we have an array with a length of 5, the last item is in index 4. And then the last argument to this is the actual array. You might not use that argument that much, but I want you to know it's there. And it just, this entire array is in this argument every single time. All right? So all we would have to do in this mapping, we would just have to return $int item, because item in this case is going to be one of these numbers. Then we will expect we're going to expect that the actual nums array should include the number 20. And we can expect the numbers array, because I told you that that's still going to exist and be what it is now, to include 20, the string. Copy and paste this, and let's just say numbers should not include 20, the number, and actual nums should not include 20, the string. So basically, we are just saying that our original numbers array, it has a string 20, it doesn't have the actual number 20, and our new one has the actual number 20, it doesn't have the string 20. And just for good measure, why don't we console log out numbers, and then we'll also console log out actual nums. Let's run it. The tests all pass. This is our numbers. This is our actual nums. So that's a map. Okay? We mapped over each of the items. We ran the function against them once. And before we jump into the data, how about very quickly, we just toss on the debugger and we watch this step through right in here. So you can see this is running through the first time. Item is 20. Hit play. It runs through the next time. Item is 10. Hit play. You can see the index going up. I'm not going to keep saying what's happening. You're smart people, but you see how this changes. You see how this map function is working. So now let's work with some more realistic data, and let's see how we might make our own map implementation without using the JavaScript one, because the best way to understand how a function or a method works is to write it. Figure out how to write it. So let's do that. How about we get everybody's names from this list? All right. So the way that we would do that is we would make an array called names. And this is how we do it the old way, but this is how we're going to build it up so that we see what's going on underneath. So we make an array called names. We're going to run through users, and we're going to push everybody's name onto this array. And we would do that using a loop. And the loop is initialized with a value set to I, and that's how we're going to track the for loop. You should know how to do a for loop. When I is less than users.length, that means we have more users to go through, and we're going to set the current user to user. So just update that. And then, like I said, we are going to push user.name onto the names array. And that's pretty much the whole implementation, because we don't have to worry about any error checking or anything. We can see with our own two eyes that everybody has a name. But let's write some tests just to make sure. So we'll expect names to have a length of 2, 4, 6, 8, 10. Should have a length of 10. So we'll also expect, I told you that mapping is a one-to-one, so names.length should equal users.length, because even though we're not using map, we're trying to build a function that works the way map does, so it's a good idea to write tests that would prove a map is working. So what else could we write? Well, I guess we could say that we would expect names to include Michael. And let's just write one more. How about we'll include Sarah, because that's the last name on the list. Let's run the test, see what happens. It ran fine. I'm also going to console log out names, just so you can see what that looks like. And here's all the names. And a good thing to note, because it might not be immediately apparent, when we're doing this loop, we're incrementing upwards. We're starting with 0, 1, 2, 3, 4. So that's the order this array is going to be. Well, we get the same exact behavior when we're working with map. So even though with map, we don't have to write this, and we don't have to do this, increment our counter, we're still getting things in the correct order. The JavaScript engine and pretty much any implementation of map is going to keep things in the right order for you. So let's take this and let's wrap it in a function. We'll call the function map. So the function can take an array and it can take a function. Now, in most libraries, you'd probably want the function to be the first argument of this, but we're not going to worry about that now. We're just going to write it this way. How's this going to work? If we want this to work with any arrays, the first thing that we're going to have to do, copy that and change names to array. Or actually, so what we'd have to do here, we're going to have a function, we need a function that's going to basically do this behavior right here. So names can be called array out. And this argument here we'll just call array in. So while I is less than array in, because we're going to put in an array, we're going to loop through it, and then for each item, we don't care about this users thing. We can change this to item equals array in, and we still keep that I because that's the item that we want from the array. Array out push. And what are we going to push? We're going to push function, and we're going to run through the function the current item that we're looping. So this is basically what an implementation of map does. And this is what it takes out of your code that you don't have to write ever again if you don't want to. And then the last thing, of course, we'd have to do is actually return that array out. Now let's use this kind of like the last thing we did with the names, but this time we're going to write a function called, we'll write a Lambda function. You should know what a Lambda function is. If you don't, you're going to learn right now. So Lambda function, we're going to get friends. And get friends is going to take a user, and it's going to return user.friends. So what I just wrote there, that is equivalent to this. Return user.friends. All right, and I'm going to keep this up just because I might need it in a moment to demonstrate something. So here we have our map method. Let's push this down the screen because we can pretend that it's not here, although it would be nice to see it a little bit. Get rid of this. How would we get from this array of users, how would we get everybody's friend list? Well, we could say friend list equals map. We're going to use our implementation of map, not the JavaScript engine's implementation. Users, because we're going to pass in array in. And then for function, we're going to pass in a new function, get friends. And then why don't we console log our friends list, run this, and there it is. And this is all the friends list that you see here. And like I said, it's a one-to-one representation. So before we move on to filter, I just want to quickly talk about some of the nuances of map. So if we were to write this with the actual map, we would say friends list equals users.map get friends. I'm going to run this again so you can see the output. There it is, same thing. So I'm going to erase this. We don't need that anymore. We know how map works. We're just going to use the JavaScript engine implementation. So here's what I would like to show you now. There is actually a second argument to map, and filter has this as well, and it's the context, or this arg. That's what we call it. And what this arg is, when you have a function, you have a context. So context is accessed with this. And this could be, if it's out here, it might be window. If it's in here, depending on whether strict mode is on, it could be undefined, or it could be window or the global in node. Not to worry. Anyway, so what would happen if we put this object here with, I'm going to write Michael, Mike, there's going to be some nicknames. We'll put Christina, Chrissy. All right, so these are some nicknames. And the reason I wrote these nicknames is I'm just going to show you what happens when we map and we have this object here set as this. So this is equal to these nicknames down here. And an easy way actually to demonstrate that is I'll actually pause the engine as it comes in here. But let's do something interesting. So I put these two names in here. I mapped the long name to a short name. And instead of returning friends, let's return name. Call this get name. But if this user.name, so if the user's name is Michael, then this Michael should equal Mike. So if that exists, do that to force it into a Boolean. We shouldn't need to do that, but it makes it kind of clearer. So that's what we're going to return. Otherwise, we're just going to return the user's name. Let's run this so we can look at friends list. Friends. Run it again. So it's going to pause as it comes through here. And the reason I did that is I just want to show you this over here on the right. is this object. You're not going to use this argument that much. You might. I don't know. I don't use it that much. But if you did use it, that's what it would do. Every time this function runs through the users list, it'll have this set to the object that we put right here. I'm going to remove this breakpoint, run through the rest of this in the debugger. And here we have the names, only you notice that Mike is Michael over here. We got the nickname, and the same thing with Chrissy. Christina was mapped to Chrissy. Everybody else, their actual name that's in their user object was put into this array. So you're normally not going to need that. We're about to change the page. I just want you to look one last time at this one line here and how we were able to reduce so much code just by using map. So you actually don't have to write a lot of the loops or pretty much any of the loops once we learn these other cool methods. So here we are. We're going to learn filter, and you probably recognize this data here. It's the same data we just had, except I've thrown in a couple of curveballs because we're going to be filtering stuff. And when you filter stuff, you need some stuff to filter. Over here, we had some pretty data. Now we have some messy data. Somehow a error code got into this and some lyrics to an old song no one's heard of. So how can we make sure that if we're going to pass this data around our app, that it's safe? And before we just run the array filter method, why don't we write out an implementation of our own just very quickly? Do that like this. We initialize a variable to track as we loop through. As long as that variable, our index, is less than the length of this array, then we're able to grab users. We'll set our variable to user. I like to change this. I should just update it in my live templates. So what are we going to do? How are we going to filter down this list? Well, the first thing we know, because I said earlier that filter and map and reduce, they don't mutate this array. You can mutate it from within the functions, so it's not like they're completely safe, but they don't do that themselves. So we'll need another array. So let's make an array, and we'll call it clean user list. And then inside our loop, we're going to be going through each user, and what could we do to make sure they're a clean user? Well, how about if user and type of user is equal to object? So that just basically says if this is an object. And the reason, if you've never seen this before, so this right here is saying that if user evaluates to truthy, you would think that this would be good enough to test for an object, but null in JavaScript also passes this type of equals object test. So what we do, null won't pass this test. It seems like one too many tests, but we need that first test so that null doesn't slip through the cracks. So if we get a user that is an object, we want to keep it, but then also we want to make sure that it's not a string. Actually, we don't even need to do that because the string is not an object. So if we pass these tests, then we're going to push on to clean user list. Now we'll come down here, we'll console log the clean user list. Let's take a look at it. And there it is. I'm going to scroll through it. And actually, I could throw a debugger statement just for the heck of it. Run this again. come into the debugger, and we can see that we have a users list of 13, and we have a clean users list of 12. So that's not exactly what we want anyway, is it? Because even though this is an object, it's not a user object. So what's one more test that we could write here? Well, let's do this. Let's take this. Let's write a Lambda function. Write a Lambda function that says isObject. It'll take a value and it'll test it just like we did with user. And if it passes, then we know it's an object. We can just drop in here isObj, and our other tests, we want to make sure, how about that they have a name? So we could say user.hasOwnProperty name. Now keep in mind that this has to be on the right side of this expression, because if this, say this string was up here and it got hit first in this loop, if this side of this expression was over here, then it would check if the string had a property name, and there could be some problems. If it was null, there'd definitely be some problems. So just keep that in mind. If you're ever testing for an object and an object property, just always make sure it's an object first. And the good thing about that as well is that if it's not an object, it's not going to also check this. That's called short circuiting. It's smart enough to know if it's not an object, then we're not going to run the second test. So you should always just run whichever test you think would fail first. Run tests in the order that makes sense. So this is a filter. We could put this into a function if we want. Let's actually do that. Make a filter function. It's going to take an array. It's going to take a function. It's going to return a list. I'm just going to cut this code here. That's pretty much what we want. The only difference is we're just going to call this clean list, return clean list. And instead of user, we can change this to item. Same thing with this. Let's change this to array. So this is going to loop through the array. It's going to take each item of the array, and then our test isn't going to be passed in. It isn't going to be inlined. It's going to be passed in through this function, through each item, through the test, like that. So this is an implementation of filter. If it was a function, not a method. So let's run this and try to get our clean users list again. So let's write clean user list equals, we're going to use our own version of filter. We're going to pass in the users list, and then for the function, we're going to have to pass in, should copy this. For the function, we're going to pass in this here. I'm going to take item, and this should work. So this is basically saying filter this array using this as what we call a predicate function. The predicate function is the function. It's the function that filters each item. It's called a predicate. Predicate's kind of like a verb, describes something, or like an assertion about something. Either way, that's the correct term that you should be using if you move on to functional programming. And if you don't, you could just call it the function. That'll be fine. No one's going to fault you. Let's run this. It might fault me though, so I kind of sound like I don't know what I'm talking about. And here we go. There's our filtered list, none of the nonsense. Since the debugger stopped, we can look in here and we can see we have a 11 length array where the normal one was 13. We could write some tests, but I think you guys are smart enough to see that this is doing its job. So let's erase this. And let's just use the actual JavaScript implementation of filter. And we can actually, why don't we get rid of this? Not get rid of it, but why don't we abstract it? Because that's kind of one of the benefits of writing these higher order functions. You abstract things and it makes your code more clean looking. So what should we call that function? Let's call it clean users. It's going to be an extra parentheses there. That looks pretty good to me. Let's run this one more time. And there we go. Here's the clean users list. So that's how filtering works. And you can do a lot of, I don't know. I don't want to leave you with just this one example because it is a good example. We did clean up our data, but then we might want to even do something else with our data, right? So before we end this, because we are at the end, I'm going to wait till next time to show you reduce. Let's do one more example that kind of has, I don't know, a little panache, a little flavor. Let's pretend that one of our users needs to filter the friends list. All right, and we'll use map too. How's that? So we're going to take this user, and I'm actually just going to paste them down here. Or we could search for them if you want. So let's say we have a Lambda function called getUser. It's going to get user by ID, and we'll just use another array method called find. So this will return users, find, and this will take a function, and the function will look through each item, and it'll return the first item that passes a test. The test we should give it should check if ID is equal to item ID, and we actually should not use users lists because we know that's not clean. So why don't we actually do this? How about we pass the user list into this function and we'll filter it out first. Does that make sense? So we have our clean user list here. The next step is we're going to get the user Eric, and the way we're going to do that is by calling the get user function, and we're going to pass in the clean user list, and that way we don't have to worry about this right here, that expression throwing us an error because it's trying to get the ID of a string or something crazy. And the second argument we'll pass in is Eric's ID, which is 319. And let's just write a test. So we'll expect the Eric variable to equal users 0, 1, 2, 3, 4, 5, 6, 7, because it's the 8th element of the array. Let's see if this runs. Cross your fingers, and it did. Success, you win. That means the test didn't fail. If you don't remember, if I change that to 8, we get an assertion error. So we have the right user. Now we're going to take the user and we are going to filter down his friends. Let's pretend that Eric's looking for a girlfriend. So he's going to filter his users, his friends, down to just females. First, we'll have to get these users. And we're also going to use filter for that. Oh no, we're going to use map and get user because we know how to map, and we now have this great function called get user. So we're going to take Eric's friends and we're going to map to get user. But first, and now you're going to see something cool that you can do with map. Before, we can't just map his friends to get you. Yes, we can, because they are IDs. I'm sorry. I was going to show you a neat trick, but we don't even have to do it. We already have the numbers. So Eric's friends. Now let's just console log out Eric's friends. All right, user list find is not a function. I'm going to show you something we can do. This is a functional programming thing. It's a cool technique called currying, and this is kind of a weak implementation of it, but basically we just made this function where we can pass one argument into it and it's going to return us a second function. So it's like we're preloading it. Sort of advanced, but I think you guys can handle it if you made it this far through this video. So we'll pass in the clean user list. Let's run this again. It says it can't get the property map of undefined. So put it in the wrong function. Oh, okay. Here we go. This is why it's a weak implementation, because now we have to call this function twice. We can't just call it with clean users list and the ID. We have to call it once with clean users list so that we can get back this function. And then when we pass in this argument here, that's when it calls the body of the function. I actually have a video about currying if you want to watch that. Very educational. So here we have Eric's users on the right. I'll throw a debugger statement here. You can also throw debuggers like that, but I just want to throw it at the end. So here's Eric's friends. It's an array of 5 users, and we want to filter out just the females. So we want to get rid of this guy. We want to get rid of that guy. And we can actually chain these together. Say filter. Now normally, think of this, right? This would be a loop here. This would be a loop here. And now this here would be a loop. I'm sure we wouldn't have 3 loops. We might be able to squish it down to 2, but we're doing this with no loops. This is very cool stuff, and that's why I said this is very powerful stuff. So how are we going to filter these people out? Well, we got to find out if they're female. So we're going to have to grab their gender property, and we can just do that. Let's write a function for it. Actually, let's write the function out here. Function to equals we'll just do string 1, string 2. So we're going to compare 2 strings, return string 1, string 2. So this will test if 2 things are equal. Filter out males. Kind of not the greatest implementation. So it's going to take a user and it's going to return user.gender equal to male. We don't even need this. It is kind of late, I guess. I'm starting to think of too many things. So we're just going to have to pass filter out males into this, and we can change this to be called Eric's female friends. Break this onto separate lines. We could break this into actual separate statements, but I think it's cool to see it chained. You might think it's cool as well. Let's run this. Last thing we have to do is that. And there we go. So it looks like we actually filtered his male friends. Do we say do not equals male? Or do we want to assert that yes, it equals females? I guess the name of the function says filter out males, so we're going to do a do not equals. There we go. So that's how this works. That's how map and filter can do some very powerful things. I hope you guys learned a lot. Let me clear this out. If you want to look at the code, I'll throw some of this code up on GitHub. And maybe I'll throw some exercises up there so you guys can try some of this stuff out on your own. But I'll definitely throw at least this data up and some comments saying the different exercises we did in the video. And you can try to do these on your own. And you should get excited, because if you understand these concepts that we just went through, and I'm serious about this, if you understand what we just went through, then you're really kind of elevating your programming game to another level. These are very powerful concepts. The more you practice them, the better you're going to get. Have a great night. Look forward to the second video. I'll be putting it out soon. And in that, we're going to go through reduce. And reduce is like both of these put together. It does some very powerful things. I kind of winged this video a little bit, but reduce, I'm going to try to think of some cool examples that showcase the power of it. Have a great night. Keep writing JavaScript. See you later.